Let's try to solve this problem of circular motion. The problem says that particle moves in a circular radius of 1 centimeter. So I have already drawn a circle. Its radius is 1 centimeter. And speed given by v equal to 2t. There was the catch of this problem. It says that instantaneous velocity v, so which is the function t, is equal to t. That means velocity is not constant. That means it is not a problem of uniform velocity. The velocity is proportional to time, 2t. By v is in centimeter and t is in seconds. Find the radial acceleration of the particle at t equal to 1 second. Say at t equal to 1 second, let's say this is t equal to 0 second, and let's say this is t equal to 1 second, t equal to 1 second, the particle is here, and they wanted to find out the radial acceleration. Now we know the particle always moves in tangential direction. Velocity always in tangential direction. And this has in circular motion chapter, we know tangential uniform velocity always has a radially inward pointed acceleration, which is a. Now, we have to first find out what is the velocity at time t equal to 1 second. So, velocity at time t equal to 1 second is equal to 2 into 1 is equal to 2 centimeter per second. Very clear? And we know the radial acceleration AR is given by the formula v square by r. So it is 2 square by r. R is given 1 centimeter. So 4 centimeter per second square. This is one answer. This was not a difficult problem at all. Now, second problem is find the tangential acceleration. That means since the tangential velocity is a function of time, and it is clear that the velocity increases with time, it is clear that it has got an acceleration, right? And I tell you, in circular motion chapter, normally you do not always get a problem with tangential acceleration, but this problem has a tangential acceleration, so I thought I must explain this problem to you. Now we have to find out what is the acceleration in this direction. Acceleration in this direction, let us say this is tangential acceleration AT. Now acceleration you can always find is time domain differential of velocity. And in our case, it is ddt of velocity is 2t. So it is 2 centimeter per second square. So acceleration is given. So we find that draw this circle once again. We find this has got a radial acceleration of 4 centimeter per second square, and it has got a tangential acceleration of 2 centimeter per second square. You can call it tangential acceleration. You can call it radial acceleration. So obviously, the net acceleration, the resultant acceleration, is the resultant of these two accelerations. So you can say find the magnitude of the acceleration, total acceleration, magnitude, resultant acceleration, magnitude is resultant acceleration is force square plus 2 square under root is equal to the 20 centimeter per second square. So the three answers of this question. Right? Now let's take the next problem for solving. Now let's take problem number 9. This also is a very simple problem, but I have taken up this problem because here the force of attraction is electrical. So you should remember or recollect your uh, for electrical force of attraction. It says that in a hydrogen atom, in a hydrogen atom, the electron goes round the proton in a circle of radius given. This is the radius. So radius is given. Find the speed of the electron. You have to find out the speed v of the electron. And mass of the electron is given and charge of the electron is given. The problem actually, you have to look into this angle that the centripetal force, the centripetal force divided by the Coulomb force. Now, remember the equation, Coulomb force is equal to 1 by epsilon 0 and Q1, Q2 by R square. Q1 is one charge, Q2 is another charge, R is the distance between them. And this is equal to 1 by 4 pi epsilon 0. You have to recollect or remember this value for all 4 pi epsilon 0 is 9.0 multiplied by so this is equal to 9.0 into 10 to the power 9 that multiplied by Q1. Here there is one proton and one electron. So both Q are charged of Q1, Q2 both are sent. So we can take it as Q square. And the charge is given as 1.6 into 10 to the power minus 19. So 1.6 into 10 to the power minus 19 square. And there is R. And there is R square. Is R. R is given as distance between them is 5.3 into 10 to the power minus 11 meter, means 5.3 into 10 to the power minus 11 meter, and whole square, right? Now, this is so far as the Coulomb force. And centripetal force is equal to V by R. This V is the velocity that they want us to know. So V square, so mv square by R will be equal to 1 upon 4 pi epsilon 0 Q1 cube, right? So V square is equal to, so from here, so this force, Coulomb force, let's say this Coulomb force here. So we know mv square by R is equal to, from here we get V square is equal to F R by N. Now you can put the values of F. F is already, we have already got F, that is 9.0 into 10 to the power 9 multiplied by 1.6 into 10 to the power minus 19, that divided by 5.3 minus 11 whole square. This is F multiplied by R. R is once again 5.3 into 10 to the power minus 11. That divided by M. Mass of the electron is 9.1 into 10 to the power minus 31. If you make this calculation, you will get V square. V square you will find 4.77 into 10 to the. From here, you will get easily V is equal to 118 into 6 meter per second. So this is your answer. Then we shall go to the next question. Now let's take this another problem number 13 of your textbook, circular motion. Here again, the problem is not at all difficult problem. I'm taking it up for your understanding. A simple pendulum is suspended from the ceiling of a car, taking a turn of radius 10 meters. So here is a car, it is taking a turn, say, with a radius of 10 meters at a speed of 36 kilometers per hour. Find the angle made by the string. This angle, obviously, if the car takes a left turn, the pendulum will take a swing towards right. This is obvious. Find this angle theta. So let's solve this problem. First we do this velocity V is 36 kilometer an hour. We convert it into MK system. This is equal to 36,000 meter divided by 1 hour makes 3600 second is equal to 10 meter per second. Next, we draw the force diagrams. This pendulum has a gravitational force mg downward, and this is the tension of the string. If this is theta, then obviously the vertical component of the tension is T cos theta, is T cos theta, and horizontal component of the tension is T sin theta. Now we put our arguments. T cos theta, obviously T cos theta has to balance mg. So T theta is equal to mg. And also we write T sin theta provides the centripetal force. Provides the centripetal force, which is equal to, we know the equation, mv square by r. And that has to be equal to, therefore, so we write that T sin theta is equal to mv square by r. From here we get tan theta mv square by r multiplied by 1 upon mg. M get cancelled is equal to v square by r. Then you simply put the values of V and Rg. V is found 10 meter per second square, so it is 10 square. R is also given 10 meter. 10 G is 10. This is equal to 1. If tan theta is equal to 1, therefore theta is equal to 45 degrees. This is the answer. Now let's go to the next question. Next question. A person stands on a spring balance at the equator. So this is the earth diagram I have already brought for you. Here is the person who stands on a spring balance. And we know the reading shows by the spring balance. We can write here shown by the spring balance always equal to reaction or normal reaction force. Normal reaction force means the force opposite to counter mg or gravitational force. By what fraction the balance reading will be less than its true weight? Right? Now, we know from some equations you have to always remember. We know that due to the rotation of the earth, anybody standing on the earth or any object on the earth needs a centripetal force. And the centripetal force is subtracted from the gravitational force, and that is equal to the reaction. Right? So now we have seen there is a formula you must have studied in your textbook. The apparent gravitational attraction acceleration due to gravity G dash is equal to G minus omega square R. This you have studied in your textbooks. So what is the loss? Loss is equal to Loss will be proportional to, because actual weight is mg, right? Loss will be proportional to g minus g dash. I shall write proportional. Loss is proportional to g minus g dash, and which is equal to omega square r. So the loss that they want to know is proportional to omega square r. And what is the fractional loss? So the fractional loss is equal to fractional loss is g minus g dash is divided by g. Once again, I write proportional because the mass m I have not yet considered. So this is equal to omega square r by g. This is the fractional loss. Now let us find out the values. So this is equal to fractional loss. We have to only find out this value. Now let us find out the value. The radius of the earth value is not given in this problem sum. It indicates, maybe you have to remember this. Radius of the earth is 6,400 kilometers. It's a round figure, so maybe easy to remember. This is equal to 64 into 5 meter. Right? And also in it, omega. What is omega? Omega is angle of rotation per second. So we know one rotation makes 2 pi radian. For any circle, the angle of around the circle is 2 pi radian, and 2 pi radian is angle is covered by the earth in 24 hours multiplied by 3600 seconds. If you calculate this, this will be equal to 7.27 multiplied by 10 to the power minus 5 radian per second. So fractional weight loss is not difficult to find out now. Fractional weight loss is omega squared. That means this 7.27, etc., this whole square equal to 7.27 into 10 to the power minus 5 whole square multiplied by r is equal to 64 into 10 to the power 5, 64 into 10 to the power 5 divided by g. You take the value of g. If you calculate this, you will find it is 0.0034. So fractional weight loss is 0.00. So one thing you should also remember, that means the fractional weight loss of any body on the earth due to its rotation is really negligible. That is why in our day-to-day life, we do not at all consider this weight loss. Then there is a second part of the question, which says Earth's rotation is increased so that the balance reading is half the true weight. What will be the length of the day? That means if the fractional weight loss is half, that means suppose your weight is 60 kg and the swing balance shows only 30 kg, then then definitely the earth has to rotate very, very fast, and our day will not be 24 hours a day anymore. It will be much less. So the paper setter wants you to find out what will be the length of that day, right? Now, here, this was part A actually. In part B, what we find, G dash is given as G by 2. That means G dash equal to this. So G by 2 is equal to G minus omega square R. G minus omega square R. From here we get omega square R is equal to G by 2. From here we get omega square is equal to G by 2R. So we calculate omega square equal to G by 2R. If you calculate G by 2R, once again G is 10 and 2 into R is 64 into 10 to the power minus 5 meter. So 64 into 10 to the power minus 5 meter. If you calculate this, you will find, I am omitting the calculation part, you will find this is equal to 78 minus 8. From here, we find omega equal to 8.83 into 10 to the power minus 4 radian per second. Now, we just have to convert from omega to the rotational speed. If omega is this, from here we can write here omega is 2 pi by total time taken by the rotation. That means day's length. Why? Because in any circle, the total angle is 2 pi radian. And if total time is t, then the radian per second is 2 pi by t. Let us draw. So from here, we come here. So 2 pi by t is equal to 8.83 into minus 4. From here, you can find out t is equal to 1 is equal to 7. T is equal to, find t is equal to t equal to 7116 second. This becomes 1.97 hour. So our day's length will be approximately 1.97 hour, rather 2 hours, approximately 2 hours. So if the day's length is not 24 hours, instead of it is 2 hours, then the reading of the weighing scale for any person will be half of what is actual weight is. So here we end it now.